go for it. All right. Should be live. Hello, everybody. If there's a little bit of noise in the background, that's my son getting ready and doing some stuff. So apologies for any noise. Hope the sound's good. Hope the audio is working fine. It's been a while since I last streamed, so it's always fun to see if everything is still up and running. Alrighty.
Worry everything broke.
Now, of course, everything breaks. Like
That's how it works.
yeah, you have fun. All right, cool. He's off to play some games. Very good. All right, welcome everybody. Yeah, exciting day today, but stream-wise, I am planning to focus on the work we were doing last stream and having a look at if we can improve this a lot, because the basics were working of our little walking thing, but the walk looks absolutely ridiculous. So obviously he can turn a bit, and then when we walk, well, that's a very fake movement of the legs, but it's a start. We've got something that we can use. Turning is definitely something that I really need to figure out how to improve yet, but we will get there. So, hey Rosella, how are you going? Again, it's just about getting something that works and trying to figure out, okay, how can I improve on that? Now, one of the biggest problems that I have here, that I'm not sure about, actually two problems that I have. One is that we kind of really needed like a recording or something, or a way to sort of see what he's doing to better debug it. I'm not quite sure what to do there. And then obviously the second thing is, it's really trial and error at this point in time to adjust this thing. So I'm wondering what I can do interface-wise to make this work. And I'm wondering if we can fake the movement, if we can tell it to do something, debug-wise. Maybe we can put something on the avatar like a test velocity, and make it think that it's moving forward, and play through the animation that way. Wonder how we could do that. Because that might be a nice way to do it, that we can just make him step in place in the editor, so we can tweak our values a lot. And I wonder if we can actually make that work just in here. That would be even cooler. We need to go. The guy needs to relax. Yeah, well, yes, he probably does. We've got nothing overridden here. So yeah, I think we're going to start with that. We're going to see if we can add some logic in here that we can, first of all, just for debugging, make him walk in place. So we can start tweaking things and see what it does, and take it from there. Now the other thing is, and I'm just going to keep this as a reference, is I looked at this little video. Let's hope that this actually refreshes. I don't know why it decided to unload. Come on. What's wrong with you? This is not like when I'm streaming that I also want to watch something on YouTube. Maybe YouTube doesn't like that. I don't know. I guess that's not going to be a resource that we're going to be using today. That is a shame. That was a nice little walk animation that we could look at and sort of compare a real person walking, but it decided no longer to work. Oh, hold on. No. Don't go and do stupid commercials. That's probably why it wasn't working. It wanted to play a commercial for me. Okay. So now I can actually see what it is, and now we can just slowly move forward. And we can see a walk here, how he's actually making a step. So we really want to go from, that's where the foot goes down. So yeah, that's basically the animation that we need to see if we can reproduce and make it actually do that. Okay. Hey Anshul, how are you going? India's not too far away time-wise for us, which is nice. Okay. The other thing that I really want to do in order to better debug this logic is see if I can make it slow down. But let's start with seeing if we can make it walk in place. And for that, this needs to become a tool script. Oh, it already is a tool script. And the other question is it actually going to do the raycasting in... I'll see. All right, so it's been a while since I last looked at this code, so it's going to be a little bit of a, how are we doing this? All right, so calculate our linear and angular velocity. So that's between current position and last position. Okay. And then we have a last transform there. Okay. So I'm thinking with that. Let me think. How did we determine how far we are in our movement? That's the thing that I really need to do. Because I wonder if it's enough to just move our targets backwards. No jump velocity. Velocity is... Yeah. Velocity. Time is wind time plus delta. Okay, so we got delta for how far we're going. Oh yeah, because we keep stepping every... yeah, we got a time factor there. So I think we put that in here somewhere. No, that's all that. So that must be... I thought we had a setting for that. Hold on. Step curve. Duration of a step is a function of velocity. That's it, right. So we made it that the faster we're walking, the more we get that. Tor, it's for anything, but I am doing it indeed for VR. I'm not a Unity person, Anshul. I'm purely doing Godot things. I've had about a day's worth of work in Unity, so I'm not quite sure if I can help you there. But yeah, for me this is for VR, but the logic that I'm building is not specific to VR, so it could be used in other things as well. Okay, so we're gonna make a new export group, and we're gonna call that debug export group. Debug, and we're going to call that debug underscore. Oh, the other thing is this whole project right now I have extracted into a new project from the thing that I was working on. It's also one of the reasons why I'm renaming a few things as I'm slowly cleaning that up. And I will be putting this into a repo soon, so people can look at this far from ready code and see what I'm doing on stream. The debug helpers. There we go. So we should now have that in here. Oh, because we don't have anything yet, it doesn't make the group yet. Export bar debug velocity float 0. And actually I'm going to make that a range from 0 to just do 1 for now. And I want suffix to be meters per second. There we go. Let's see if that wants to work. There we go. Boom. Cool. That should be turned off right now. Cool. All right, so with that velocity, we are going to make something here. Where are we? So that is our current. I think if we change our last velocity, so here what we're going to do is, no, do not run this in editor. I do want to run this in editor. That actually needs to become a debug function, I think. Bar debug enabled false. Enable debug mode. And then here, there we go. Okay, so now editor hints do not run the rest in editor. So we probably need to switch that, and then when we do that for the first time, turn this on after all. So what we really want to do is not debug enabled. That, and I want to do the same here. Not debug enabled, and engine is editor hint. Then we just get out of there. Cool. And then we're actually going to make our debug enabled a property. We're going to give that a setter. Set the value. All right. If value is, oops, not for this one. Needs to be there. There we go. So if we're already set, then no, actually, yeah, no, that's good. So if we're already set, then we're not going to do anything else. We're going to go and assign this. If is inside tree, they're going to say update debug enabled. And we're going to do set progress. Oh, because I haven't created this yet, it's going to not let me do that yet. So let's put that in place first. Let's just put it here at the top. Why not? That's for now. And actually, that stuff can run always. Do I care that these are already in top level? I don't. Is there anything against? Yeah, that's the reason why I didn't want that top level in the editor, is that moving the character around. Okay, so I just need to be smart about this. Actually, I want to do not. Then I'm going to do this. That's part of. What is debug? Oh, that's just the UI part of it. Okay. So that's something we're gonna need to offload eventually. But that is going to be part of that. Okay, so now we're just gonna do update debug enabled. Boom, and then this. We're going to go and move in our update debug enabled function. Boom. Oh, thank you, Asterion. That's really cool. I think you're the first one to give me a donation on stream. That's really cool. Thank you.
Someone donate.
Yeah.
What was that name?
Asterion. What is that your mint?
Yes.
All right, one of your friends. Very cool. Hey, why not? Always like having my son's friends on the stream. Tor, an overview of the whole design. Let me finish this little bit and we will talk about that. So what I want to do here is this should be debug enabled or not. We need to go and repeat our, because we never want to turn that off if we're in runtime. Hi, Cooper. How you going, buddy? Welcome to the stream. All right, do this as well, but then here, that's gonna go like that, but then also on ground debug visible is gonna be that, and the same for off ground visible. Okay. So with that, I probably broke everything, but we will see. Oh, I don't want that. Okay. So in theory, all right, so that they obviously we haven't got the logic working yet, but at least we've got our thingies there. Hey, Derb. Well, you know, we all got to start somewhere, so that's all good. All right. So we haven't completely broken this yet, but that's cool. So Tor, in a really quick overview, what we're trying to do here is to make the character walk purely by manipulating it in code. So there's still a lot of things to do to improve this. You know, the character, I'm not doing anything with the upper body. The arms are currently, there are IK nodes for that, but the idea is that those would, in VR, will be controlled by a controller. So I'm not animating the arms at this point in time. I'm thinking about doing something where there is some animation in the arms as you walk, but based on the grips, but that's really going to come at the end. I do need to start working on the upper body right now. Part of why we have such an unnatural walk is because we're completely stiff on our upper body. In reality, when we're walking, our body would go up and down. We would lean into our walk. So that is something that I still need to do. for now, at this point in time, I am purely looking at animating the legs, and there's still a lot of stuff missing here, but it is working. Stasis, it is a character that was created on Ready Player Me, which is a website that allows you to create characters specifically for VR. They've moved on a lot from when I created this one, but the nice thing about their system at the time, and I think for the most part that part still works, is you can take a photo of your face and it will select from its preset something that is as close to your face as possible. So yes, while not completely accurate to who I am, it is as close as it could get based on my photograph, and yeah, it's not a bad likeness, you know, if you compare it to what's in the camera. Well, Derp, it's a lot of fun to do a VR game in Godot, and unfortunately, we're not looking into sort of the beginner stuff today, or I could possibly help you along. You are indeed making it a little bit hard on yourself being on Linux, because sadly VR is badly supported on Linux at the moment. Although you can get very far if you if you have the right hardware and right setup. If obviously you are using a Quest, then you need to push out builds to the Quest and just use Linux for building. But if you have hardware that is working on Linux, especially if you combine it with, say, Monado as an XR runtime, you can get pretty far. But it is indeed not very beginner friendly. He wants fries, does he? Well, then he needs to order some online. He shouldn't ask me while I'm streaming. This is going to be hilarious, being interrupted in my stream by my son's friends. That's going to be interesting. Anyway, so yeah, Derp, I would recommend you give it another try if you really are interested into it.
In my defense, I told them not to.
It's okay, like, I can take a joke. And he's losing money, not me.
Yeah.
What was I saying? ALVR, yeah, that would work as well. It's kind of hard to get the Ethernet, and I don't have a link cable. Yeah, that makes it harder. I haven't used ALVR myself, but I do know that there's a lot of people in the Godot community using that to do PCVR stuff on Linux. So yeah, in theory, if you get it up and running, it should work pretty well. And then just the normal beginner tutorials that you can find online should get you started. But it is that first little bit that's always a problem. Anyway, I was explaining to Tor just a little bit of an overview of what we're building here and how this is working. So as I said, the upper body is currently very stiff. So we're purely animating the legs at this point in time, and this is really early days. But what we're basically doing, and you can see these circles flashing. These circles are little helpers that I've got to sort of see what's going on. But basically, whenever you do a walk, there's one leg that is on the ground, and there's one leg that is moving forward to try and step somewhere. Oh, that's always cool, Derp. So I don't know if you can post links in the chat, but else, I don't know if you're on the Discord or anything like that. Do post your link to your stream. I always like checking in on other people who are working on stuff. So yeah, as you can see, those circles sort of split between the left leg and the right leg. There's always one leg that's on the ground and one leg that is moving. So what I'm basically doing is, as the character moves forward, you can see that red circle being on the ground. Basically, what I'm looking at is the leg that's currently in the air. I am trying to determine, based on the velocity of the character and the orientation of the character, you can see as I turn that circle sort of changes where it ends up. So based on the current velocity and direction of the character, I'm determining where I want the foot to land once I complete a step. So there's a certain step velocity right now that we have, which is based on the velocity of the character. So the faster the character moves, the bigger that is. So the run thing is really bad at the moment, but we're only just starting with this. But that's sort of determining where that foot is, and I'm basically trying to animate my why is this suddenly stuck? My IK point for my leg to that. So the character is moving forward, the leg on the ground is staying on the ground, and the IK immediately makes that leg stay there as the character moves forward, while at the same time I am moving the other leg towards the location on the ground, and I'm trying to do that in like an arch, and that's the bit that we play around with to try and make that step as natural as possible. And we actually see that it isn't natural. It's a really weird way that we're moving the leg forward. So that is a part where we need to start looking at the a real animation and trying to figure out, okay, how close can we get? But in order to make that easier, I want to add some debug functionality so that we can make our avatar walk in place in the editor, and we can change all the values in the editor and see how that affects our walk. And you see, how can we do that? And for that, we need to do some debug logic in here. And maybe I'm actually going to always make the logic run so that if we actually move our character, we actually get, because this is the problem that we have now that we got debug on, is that our position stays. So, yeah, let's go and move that guy back. Should OVR development using an Android phone possible, like one of those cardboard things where you drop the phone inside? Stas says yes, we do have two options for that. One is that you can install Monado on your Android phone, and then you can just use OpenXR. The other option that you have is that in Godot, you have a interface called the mobile VR interface. You can see a little bit of code here that initializes that. That does a very basic cardboard implementation. That one does have an issue currently on compatibility renderer, so you have to use that with the mobile renderer for it to work. But yeah. Discord link does not work. Have I got the old Discord link in my description? And how can I change that midstream? I'm going to have to make a note and make sure that the correct Discord link is... Oops. Come on, don't do that to me. Link. All right, so... check Discord link on the videos. This is the downside of Discord, is by default it makes Discord links that expire in 7 days. And while I do have a Discord link that is better, obviously my default description has the old link. Yay! So sorry about that. I will correct that after the stream is finished. Rotating feet might help a lot. Yeah, there's definitely there's definitely something that we need to do there. And indeed, Stasis, there is actually an IK point here that also affects the knee, but yeah, link worked for me. All right, then maybe David was looking at a different place for the Discord link. It's possible. There did used to be a link that expired in a long time ago since I set it up. All right. Actually, so we are actually going to make this a little bit different. I'm actually happy enough to keep this top level, and then this purely working for. So this is also more the debug UI. This is eventually going to disappear, but that's okay. So let's go and take that out. And instead, what we're going to do in the ready function is Actually, if we're, where is it? Why? Ready here. Good. I'm actually going to take this whole thing out. Instead, I am going to make the left foot target and right foot target. Oh, that needs to be on the avatar. So we got our default left foot, default right foot. Where are my targets? Ooh. Oh, they are variables. So what are they being set to? So our left foot target is our default left foot and our default right foot. So when we look at default left foot, that is going to become top level, and our default right foot, that is going to become top level. There we go. And that means we can already see that that screws up right away, but that's fine. Cool. All right. Although I'm surprised that that actually... Is that because we've got this guy rotated 90 degrees? We'll deal with that in a second. I just want to double check. Character body is probably rotated 90 degrees, isn't it? Which should be fine. It should go out. It's actually 180 degrees. How do I like to plan to stream? Probably till about 11ish my time. So for another 2, maybe 3 hours, something like that. Usually I try and stream, you know, for about 3 to 4 hours in total. The feet are backwards because I just made the targets top level, which means that the positioning is in global space instead of local, and our character body is 180 degrees turned. So my body is turned, but my feet are still in the original position. And as you can see, when I'm moving this guy around, you know, we get that IK working wrong. So obviously, once we actually get our IK working in the editor, that will correct itself. Ooh, nice and early. Alrighty, so we've got those, we've got that. Let's just slowly start getting it to a point where it actually runs in editor, and I no longer care about that. So that's the only place I still have this. Okay, that's cool. I forgot the set the set process. So that explains some. Bum, bum, bum. Okay. All right, so now we can already see that our feet are now correct. I do still want my debug things on so that we can at least see that. All right. But there's more logic that we are not correctly running at the moment. And again, that's because originally I made this all to only work in runtime. All right, so if I move you forward, all right, that's not doing what I am expecting it to do. Any errors I need to be aware of? Nope. All right. So we've got those on the last. We've got those set to always be top level, which means that they're local, or sorry, global coordinates. So the debug enable, when we go there, is just handling the visibility and the fact that our ground debug stuff is working. That's fine. So other situations that doesn't do anything. Okay, so when you look at Godot, and it is very tricky to do this properly, but if you add this at the top of your script, so this add tool line, this tells Godot to also run all the code that you've got here in the editor. So normally when you create a class on a node, the code that you write only runs when you actually run your game. The moment that you do this, this code also starts running in editor. Now, that is incredibly powerful, but it's also incredibly dangerous because I'm changing the code while the code is actually active. And what you'll see me do from time to time is reopen scenes so that it reloads everything, because as I make changes in here, Godot will get confused that, hey, I've added stuff in here that wasn't there when the scene got created, and it doesn't know what to do with it. So, I'll very often just go and reopen the main scene, and we can actually already see now it's actually doing more. So that was actually a good thing that I did. Now, what you can also see is when I'm now moving it, some of the movement code is actually doing something. It's not doing it greatly because it wasn't designed to work in editor, but the code is now executed while we're in editor, which is pretty cool. Now, one of the things that, of course, I should not have done is do that like that. I actually need to move this guy. Now, the problem is because I'm moving it in a way that we don't have a nice solid velocity, it gets very confused. But it's something where part of the logic is now already working in editor, and that's also one of the reasons why the foot is now standing so weird here, is because it's calculating that velocity wrong because it doesn't know what to do with it. However, now that it's completely working in editor, we can start adding stuff in here to tell us what it's actually doing and see how it changes when we are manipulating the character in the editor. And that will help us fine-tune this logic. And again, switching between things like this, it does get it very confused. This is the other problem that it has, is because there's things shared between these guys. It sometimes gets confused of what it's actually working on. But small price to pay while we're developing for some really, really cool and handy logic. All right, so with our debug on, we have that. Cool. And when you wanna play around with tool scripts, start with something simpler than this. But it's one of Godot's most powerful features when used properly. All right. Are you using inverse kinematics? Yeah, this is all inverse kinematics. It's a very basic inverse kinematic. So if we are looking at our avatar scene, we can see that we have our character here. Character has an armature, which is just actually this is just a helper node from the import, but it has an armature. So here's a skeleton thing that we have. All the meshes. So this is just imported. Everything that you see here that's yellow is coming directly from the GLB file that I've imported. So this is coming directly from the asset that I'm using here. But then you can see that I've added these skeleton IK 3D nodes in there, and that's Godot's inverse kinematics logic. It's fairly simplistic, but it does the job for what we want to do here. So this is the inverse kinematics to position our left hand. So that's that guy. And what I'm doing here is a couple of things. First is I'm saying it's going from the left arm bone to the hand. So if we go back to our skeleton here, we can find our left arm bone. So we're starting with that bone and we're going to the hand. So these 3 bones are being controlled by that IK node. And the other thing then here is that I have a target node, which is pointing to that one, default left hand target, which is default left hand is this target. Oh, sorry, that's the foot. That's this target here. So as I, why is that now? Sometimes screws up. That is not enabled right now. Why is that not enabled right now? Yeah. Oh, that was turned off. Okay. In editor, you need to click this play IK button for it to actually do something with the hand. And then you can see that my IK is working. So, cool. And it should have done that automatically. I might have actually got these off in normal time. I'm not sure. So I've got that purely in the override. Is that a property? Hence, IK enabled. So I've got overrides there. That's to assign to my controllers if I want to follow my controllers. But it is enabled by default. So I'm guessing this is one of those cases again that because I closed it, it resets the IK whenever you're editing scenes. It just isn't very good at keeping track of that. Same here as well. They're now active. So sometimes the IK gets disabled because of that sort of thing. Now that means that my foot is something wrong with that as well. That should not be 30 degrees. Oh, of course it's 30 degrees because we've got automatic logic running. And that's obviously not, it's not finding the floor there. Okay. 59 exchange, finished implementing a procedural walk using standard IK target step. As well as velocity cell step variant, super difficult. Yeah, it is. I am far from finished with this. This is still very, very simplistic. Dr. Offensive, no, I am not vibe coding. Absolutely not. I'm an actual real programmer, so I don't do vibe programming. What else? Is this going to be a full game or used in another game? Right now, this is purely meant as an experiment for me because I wanted to just get this working. I did build it or start building this because I wanted to use this as part of a video that I was working at and want to get back to. However, if this is successful and we turn it into something that gets shared, then yes, it's very likely going to end up in a game at some point in time. Let's see. Full body IK stuff. In theory, it's not really an extra tools, but it is part of what we have in Godot itself. However, the only things that currently support full body stuff is obviously the full body extension that Meta has. So we've got that available. Oh, Dr. Offensive, you are going down a dangerous path there, dude. You do know that I'm one of the core developers of Godot and that from day to day, I'm always working in C++. The reason I do not do this stuff in C++, well, this might be something that would be worth at some point converting to C++. But for game logics, GDScript is just very easy and nice and simple and quick and fast and does exactly what it needs to do without introducing a whole lot of complexity. So why not? So no. Yeah, Dr. Offensive, why not? That's the name that you use, and that's the name that I'll use, unless you do something really bad. But where are we? Try using ChatGPT to make misunderstood. Okay, now you're just trolling. So that, yeah. Yeah, Derp, Hades, I am completely on board with that. GDScript actually it's a really solid language. It's really good for what we use it for. I wouldn't write a renderer in GDScript, but that's not what it's intended for. But as a scripting language to script game logic, it is actually really good. Better than most options that are out there, in my opinion. And the level of integration of the language into the engine makes it worth using. Anyway, keep getting real programmers write assembly, noobs. Yes, let's go and do assembly code. I haven't touched assembly since I was a kid. It was a lot of fun though. There was a time that I did everything in assembly, but that was also a time before we had graphics cards and stuff like that. Yeah, no, I'm actually using the static optimizations mostly for, just making the what you call it, like the drop downs. I can't remember what the word for it is. My English is failing me today. But like the auto completion and stuff like that, I don't really believe in it for a performance standpoint. if you are doing something in GDScript that is incredibly performance sensitive, that's the point where you need to start thinking about porting something to C++ and into a module or something like that. But the realization is that for most of the things that GDScript is intended for and what you would be writing, it's not performance sensitive, so it doesn't really matter. And Dr. Offensive, if you love C# and you love using C# in Godot, then all love to you, dude. That's a valid choice. Can't blame you. You know, I did C# a long time ago. I liked it. I stuck with C++. And I like GDScript for this because of the level of integration and the fact that I don't need to run through a compile. So it speeds me up in development time. But C# is good enough, and it does a lot of things better than GDScript. So why not? You know, if you want to use that as your main language in Godot, then yeah, perfect choice. Nothing against it. Anyway, I'm getting really distracted now about what we're doing. So we obviously have that. Okay, so I'm doing that here. What am I doing? Do I not have a getter and setter for that? I do. Oh, I just repeat it there. Okay, that's fine. Again, I wrote this code a couple of months ago, and I've forgotten half of what it does, but that explains that one. So the thing that we now need to figure out is why our character is standing so weird. It's actually supposed to put its feet nicely to the side, but we can see that it's putting one on the center line, and it, you know, it is still kind of working. I think I need to do something. Yeah, there's something in the way that it handles the velocity that's not what we want yet. But that's to be expected because it's not designed to do this. And we're going to need to change it to make it work. So let's go and do a code review of everything that I wrote a couple of weeks ago and see if we can figure out why it is behaving the way that it is in the editor, and seeing if we can fix it up. And hopefully we'll actually fix a couple of things that way. And it'll give new people a chance to follow along with what we're doing. So we always store that. That's perfect. So we now know what our global transform was at the start. The on ground transform is taking the foot that's currently on the ground and remembering that so that we can keep that foot on that spot. Although that should actually never change while we're moving. But we have it. Yeah, it's a lot of logic that we put in here, but a lot of it, you know, one thing that you have to keep in mind is what I really like to do is make tool scripts to make things work in the editor. That means that there is a lot of code extra in here. Like all this sort of things is not just setter code, but it's also code that's written in a way that it actually works in editor. So there is a lot of extra code in here purely to make that sort of stuff work. And that's a personal preference. Other than that, yeah. The heart of it really is, so in our ready, we're just setting things up, but then the heart of it starts in process where we are doing a logic. So the first thing that I'm doing is I'm calculating an inverse global transform of our current global. That's just, that's a semi-expensive calculation. So I like to remember that. Now I'm also doing that as a global. So why am I doing that? Because I'm also using it in my raycast logic and stuff. Okay, that's cool. That makes sense. So I'm just trying to avoid having to do that multiple times, and I want the value as it is at the start of my process. So calculate and remember inverse of our global transfer. This sort of comment is doesn't really help anything because you should understand that from the line of code, but I don't really like to have just a line of code with nothing. So this is a more useful comment where we're actually saying what we're doing, not what the code actually does, but that's a personal thing. All right. Countless games that are CPU limited. Jan, that is right, but that really depends on the type of games that you're making. And on today's hardware, unless you are targeting mobile phones and stuff like that, um, yeah, you have to do some next level stuff to start getting into CPU limited territory. But again, like I said in the beginning, when you get onto the type of code where something like GDScript would not be performant anymore, like for instance, a good example of that is code that generates meshes. You should that's the point where you should switch away from C++ and start optimizing in another language. But that's a nice thing that I like about Godot as well is you can do the heart of your scripting code, your game logic in GDScript, and you can do all those things that actually requires performance in other stuff. And up until then, even for something like this, once this is all finished, it might make sense to convert it into a C++ module or extension for performance reasons, but you can still do all the prototyping in here. Countless games. Godot has always made more sense to me because I'm a very visual thinker. Oh yeah, well, Derp, you're not alone in that opinion, and I think a lot of people really enjoy Godot because of its very visual setup in how you put scenes together. So that's true. Andre, why am I doing this in process instead of physics process? Because the logic that I'm writing here only needs to run once per frame. There is nothing that I'm doing in here that affects the physics because I'm purely positioning my avatar. When I look at my character body, on the other hand, I am doing everything in physics because here I'm actually moving my physics character and doing, collisions and all that sort of stuff. But here I'm purely positioning my my avatar in a way with the walk cycle. So doing that in physics process, you just do it, especially if your physics process isn't keeping up. You just do overdoing the amount of work that you do. So that's why I'm choosing to do process here. Directly lateral movement is most troublesome to make look believable. Yeah, it is. I agree. I am, like I said, this is only my my third stream on this subject. But last stream I actually started from scratch. First stream was sort of my first failed attempt at this. So I expect that I'll be busy for a little while before this is anywhere near nice enough to really be called good. But yeah. Jan, AAA, yeah, no, in that perspective, yes, and again, it really determines on what it is that you're doing. Obviously, when we're looking at something like a game engine like Godot, everything that's that performance intensive should be solved in nodes or in core of the engine. The person creating the final game hopefully is not dealing with that as much. However, if you want to do something very specific or very unique, then yeah, that's point where you really need the performance that a language like C++ gives you, because you are really bottlenecking on your CPU. A good example. Don't know if anybody follows them, but Corey, I think his name is. Who is working on like a terrain system, like a AAA level terrain system. And yeah, that is, he's going to the point where he's doing a lot of work and offloading it actually onto the GPU, stuff that you would normally do on CPU there through compute shaders and stuff like that to make, very large detailed terrains. And yeah, it's a lot of fun to follow his work. And that is definitely the area uh, where you really start stressing your CPU and even start offloading a lot of stuff to the GPU if you can get away with it. Okay, so okay, I'm starting to wonder, is it because I now have no, where we're going all right there. Right, even if I reload that, no, then it of course goes like that. Okay, I'm just wondering if our startup point is getting screwed around because of our logic, but it should actually solve that back. Although that's also sort of, this is where I really didn't want to have top level on these things. But I think after one step that corrects itself. So I'm not going to worry about that too much. But it is something that we probably want to do on a whenever we unload the tree, is reset some things. Or maybe even when we figure out that we haven't moved and we're in editor, we put the feet back into like default positions and we stop the foot animation. But again, that's for later. We actually need to detect it at the end, that if we've stopped moving and we're on our right foot and everything is finished, we stop the animation logic. All right, so what are we doing here? So we're calculating our current velocity. So we're taking a velocity in global space. We are then converting that to a velocity in local space. Should probably call that local velocity, but then again, it is also the linear velocity. So what's in the name? We are getting the amount of rotation that we have so that we can get an angular velocity. That's for doing our rotation. And now that we've got all our velocity information, we are storing our current global transform as a last transform so that next time around we can get all our velocities calculated. So we're not averaging velocities in any way. We're actually taking the velocity for this frame. And then obviously in the editor, because we are just moving things by mouse, we will have a high velocity for that little bit of movement, and then we might have a couple of frames where we're not moving at all. Depends on how quickly the mouse update works. So that is where the movement gets really funky because of this. However, the way that I've written this is that when you start a movement and it figures out that it needs to move the foot, it will determine how long that movement will take. There's a curve that we define here, which is a step curve. And if I make that larger, we can see that if we don't have any velocity, we don't have any time for our step. But then for a slow movement, we have quite a high step velocity. And then the faster we run, the quicker we make our step. So this is one of the curves that we want to start optimizing depending on how fast we're moving. Okay. So here we're going to say if we're moving our left foot, then we're going to move that foot, and that function returns true once we finished a full step, in which case we're switching to the right foot. This is purely adjusting the magnet for IK. So when we are looking at our, let's say our left foot IK here, that is taking a target as before, which is where does that foot need to be standing. But we also have a magnet set here. And I actually have a helper node that shows us where that magnet right now is. And that's just a little script that is continuously copying the logic across. And I've got that always running. For some reason, I added only an editor option there, but right now I've got that always running. So the magnet is always updating the position here. I'm not sure why that isn't just a target node or a magnet node or whatever, because it makes it so much easier to position. Having the values here is really annoying in my opinion. Now, the other thing which is interesting is this actually a magnet that is supposed to be in global space? It actually doesn't tell us that. I think it's in local space, which I'm actually also doing because I'm taking the local position. It's a child of the IK, so it will be in local. Perfect. So that's exactly what it needs to do. Again, it's been a while since I wrote this, so I'm trying to remember what it does. So all I'm doing here is I'm updating that magnet position based on where my target position is, so that it's always slightly above the target position. And that's making sure that we've kind of got a nice arch in the leg. And that's another thing that we potentially need to play around with to get the animation to be correct. Okay, cool. So that's really what we're doing when the left foot is the one that's moving and our right foot is on the ground. All the logic happens in the move foot function, and we just have, update the magnet to make sure that our IK looks okay-ish. And then if we finish the movement, we switch over to the right foot. And then the next process loop, we're actually going to be in this side when our foot moving is the right foot. We do exactly the same thing, but now instead of our left foot target going in here, we're now going to get our right foot target being the target that we're moving. Finally, we have a value here that should be reset at the beginning, I think. Somewhere we're calculating that and then copying that. I'm not quite sure why we're doing that. Oh, because we have an overrule for that. So we're basically checking whether our foot is actually currently on the ground. And that will always be updated based on the foot that is currently on the ground. We're checking if we have a character body, and this is just the extra logic that I've done. This is something that we need to look at as well. That's to make sure that our character body can actually fall. But, because as you can see on our main body here, our collision scape for our character body actually ends at the bottom of our, the midsection of our body. So normally if nothing would happen, our character would just fall to the floor. So we have some logic that if the feet are on the ground, we are giving a little bit of upward force onto the body to keep the player upright. And the nice thing about that is that, for instance, and I can show that real quick if this is still working, yes it is that when we go upstairs, we're actually moving upwards. Now, there is a bug right now. We're no longer falling. So that's another thing to fix tonight, because that was working at some point. Okay, so when we're looking at this with the semicolon float, there is a reason that it's supposedly slightly faster, because Godot can optimize some things. I don't really care about that, but it means that our editor knows exactly the type of value this is. Now, with something like floats and ints and stuff like that, that really doesn't matter too much. It can usually infer it from what you assign to it, and there isn't really much help that you get. But once you start doing things like, for instance, casting something to character body, or like here where delta basis is basis, this means that when I do delta basis dot, I actually get proper autocompletion for that type. So I'm actually getting all the functions of basis in there. If I hadn't typed that, and Godot cannot figure out what sort of value this is, Godot can no longer do our autocompletion. So the more information you give to Godot, the more Godot helps you. The code will work without this. When this runs, Godot will figure out, oh, I'm having a basis here, so a basis being assigned to this, and it knows that that is a basis. So it doesn't make the code do anything more, but it just helps the editor know what this variable is supposed to be. And that means that the autocompletion works better, and it just helps you a lot. So, and you'll see that I'm doing that inconsistently. Like for instance here, I didn't put the bowl here. I can for completeness sake, but at the same time, it doesn't add anything there. So yeah, it's something to get into the habit of, and definitely when it is node types and stuff like that. Especially, for instance, if you look at the onReady vars that we have here, the fact that I'm assigning this to skeleton, that it knows that that's going to be a skeleton node, the autocompletion suddenly, shows all the properties and methods of skeleton there, and just makes coding a lot easier. Easier to read when I come back to it. Yeah, Jan, that's definitely something I agree with, is the more stuff you add in like that, the easier the code becomes to read. And especially, like now I'm coming back to this code, 3-4 weeks later, this is helping a lot in knowing what it is that I'm doing. So yeah, that is also a really good point. Yep, derp, that is true. Is the autocomplete can be really really good, and especially if you do things like this to help it. But um, it has its issues. Let's just keep it at that. All right, so we know now. I went there a little bit too quickly, but we know now that this logic is pretty much working. There is obviously a bug in this because we're not falling down. So we're keeping the foot on the ground even when we're off of the little stairs that I have as a thing. But I'm not going to worry about that. That is something for later. We first want to make sure that our logic runs properly in the editor and does something sensible. So we are going to do our movement logic. Now, what are we getting in here? We're getting a reference to the node of the foot that is in the air and basically the foot that we are moving. We have a reference to the node that's on the floor, so we can see that when we called that was left and right when the left foot was in air and right left when we are in the other way around. So that allows us to create one set of logic that works regardless of which foot is in the air. We have an offset vector. This offset vector, and we can go quickly back to our ready to see what we're doing there, is we have an offset variable calculated somewhere. I think that I'm calculating that again based on velocity, so that the character stands with this feet a little bit wide when we're standing still, and the faster we're moving, the closer we put the feet together. Pretty sure that there is a problem with that because of the velocity logic. But the idea here is that we always want the left foot to be slightly to the left, and we always want the right foot slightly to the right. So we have a vector that allows us to do that. Obviously, we have our linear velocity and our angular velocity calculated, so we're setting that. And we are giving us our delta so that we can do any frame-dependent logic there. Cool. So what we're seeing is that we're taking the up-down velocity out there. This probably needs to be improved at some point in time. If we don't, we're assuming right now that we're always upright, but there might be a situation at some point that we're gonna walk around the globe with a point gravity. Then this will break, but I'm not gonna worry about that right now. Now with our y movement taken out, I'm going to calculate our velocity as a meters per second value by taking the length of our velocity. So that is an important input that we do. I'm adding a little bit of velocity for if I'm turning. This really is a bit of a hack, but it works. It's just to make sure that when we're standing still and we're rotating, that I have a little bit of velocity to work with. So this is where it then becomes important that based on how fast we are moving, we are saying how much time is our step going to take. So when we're standing still, and again, this is that step curve here. So when we're standing still, we have a minimum value of 0.1. So we're saying that, a tenth of a second, we should step. So even when we're standing still, I'm continuously switching from left leg, right leg, left leg, right leg, left, right. Even though I'm not actually moving, I'm still doing that. And eventually I'm planning to do a little bit of sway in there or something like that. Something that I'm also planning to do actually is that we'll have multiple sets of these based on, are we standing still? Are we walking? Are we running? But again, for now, I'm just doing that. So yeah, that is something that we're calculating and that we're updating for that frame, but we're keeping that as a member variable so that we can use that throughout our code. Cool. So with that, we have a variable called time that is continuously increasing by delta, but we are limiting that to our step time. So basically, this is a value that goes to 0 to well, actually, the factor is going from 0 to 1. Time is going from 0 to our step time. And that's sort of how we calculate how far along our step we are. So obviously at the beginning, that's 0. That means that we've just lifted our foot above the ground. And once we're at step time, that means that our foot needs to be back on the ground. By creating a factor that is therefore between 0 and 1, that is really nice when we have all these curves, because we can nicely grab a value in our curve based on that. So, oops, did not want to add a thing there. So far so good. It's still working the way that I am expecting it to do. So with that all, we are making a target transform, which is something that I will be looking into in a minute. But basically, this is the code taking our current offset. So that's whether our foot should be slightly to the left or slightly to the right. Our current velocity, our current angular velocity, how much time we've got left, and it's going to use that to calculate where our foot should hit the ground. So yeah, that is what that is doing. So we're figuring out where do we want our foot to land, and now we've got where our foot currently is, where our foot is going to land, and we can make the animation based on our factor for moving our IK point, our target point, from the old position to the new position. All right. Convert to global. So that target transform is in the local space of our character. We're transforming that to global space because our IK works in global space and we need it in global space. Next, I am going to test whether there is a collision. So now, based on where our target is, I'm doing a raycast down to see where I can land. And that is to make us go up the stairs, or actually be able to go off the thing. And that's one of the things that is actually interesting, whether that properly works in editor, but something to look at later. For debugging, I am assigning our target transform to that node so that we can see where that is placed, so we can always see where is our feet going. That is why when we run this, we can see that our red circle is always at that target position that we've calculated. So that shows us that our target logic is working. I'll raise that slightly up because else we have Z fighting with the underlying surface. And finally, I am moving my in air to that location. So obviously the orientation I'm just doing as is. I'm happy with that. But I'm lerping the origin from where I am right now to the, where I am right now to our target based on our factor. I'm wondering if that should really be from our original position, but that is something to look into. And then I'm adding a height based on our step. That's also good. And finally, I'm doing some rotation of our foot. And again, this is to make sure that when we're rotating that we sort of figure out how our feet is going to be placed. So yeah, that is pretty much looking the way that it is. Now, finally, we're doing our on ground foot. Why am I doing something there? Rotation factor. This, I don't remember why I'm doing this. Because this is the foot that's still on the floor. Basis times rotation basis. Factor. Foot max rotation. Oh, this is that movement. Yes, now I remember. So I've actually got a rotation curve here. And the first half of the rotation is how much we rotate our foot that is off the ground. But we also have a rotation on the ground. That means that as we're moving forward, we're slowly moving our foot that way. And And it's actually interesting that I must have already done something to make sure that the feet stay on the floor. What did I just move? This one. Yeah. Oops. Now I've put that curve point back in. That's not what I wanted. This is always the problem when we're okay. So we can't really. Don't do that. That was dumb. Don't save. All right, that's always the best way to make sure we're back to where we are. So yeah, it's a little bit hard to show here, but we should be able to show that when we're doing this. Actually, when I look at this, I think I might have disabled that because our feet aren't rotating, or definitely not rotating correctly. So that is something to look at, because that I either broke that or we did something else wrong with that. Is there anything here? No. Yeah, so that is definitely something to work on some. All right. So here we're checking if we are colliding. So that is part of our raycast. Yep. And time is feet step time. So if we have reached the end of our animation, we are flipping. So why are we not doing that at the end if we're not colliding? Because that's the reason why we're not falling down. So that's something that I need to look at as well. Well, that's definitely something that I need to look at more, because there's definitely something going wrong there. Okay. So why do you type? Why do they have their hands up in the main but not in? Yeah, so that is to do with the fact that in order for the IK to work, IK needs to be enabled. And because I am editing and the editor's continuously resetting our editor script, it loses the fact that I've got the IK enabled in this. And that's why I sometimes have to reopen scenes before it's, because you can see that's already gone wrong again there. Now when you reopen it, then yay, we're back to working. So this is just where Godot is not very good at keeping that information in check. I think it has to do in part because our ready function only runs when the script first loads, but when I switch tabs, it loses a lot of that information. So yeah, I could probably fix that by doing some extra logic on an what you call it, enter tree and leave tree sort of functionality. But it can't really be bothered, because once this is all working, that wouldn't be something I care about. Sometimes just having to reload the scene is good enough for me to see if everything is working. So yeah. So that's why it's sometimes, it's just the IK turning off, basically. All right. So we want to do the debug movement. So let's just start there. Now, am I going to keep the debug enabled? Because I just want to do, because now we've already decided to always run. So I think, yeah, so the debug enabled is just going to be whether we are showing stuff. So whether we are showing this. Yeah, that's cool. And that's actually part of the UI, and I'm probably going to remove that eventually. So I'm not going to worry too much about that right now. So the debug enables purely, do we visualize stuff? So I want to go and make sure that that's properly set on that. So acting out. If enabled, we show our. And we're probably going to add some more stuff in there as well. The more we can see on what's happening, the better. So that's going to be off by default, because when we use our avatar, we actually don't want to see that stuff, but in here we do. So that's going to be off by default. Perfect. So add a constant velocity. So let's start working with the add velocity, and we're going to have to do some funky things to sort of make that do what we want to do, because we're faking it in this case. And the nice thing is, because we're doing this, we can actually do it here. So one of the things that I want to do is I want to make sure that that's not used anywhere else. So we can purely mess about with our linear velocity here. So here what we're going to do is if debug add velocity bigger than 0, then obviously we're first going to go and add that to our linear velocity. Now our linear velocity is in local space already. We are moving so the quickly show that. So the shoulder height is just to say how high are we. So if we lower that, we're crouching. We're crouch walking. And then obviously you can see how much does it break. So again, one of the many things that we need to fix. But yeah, this is the idea of are you standing up or are you crouching down? So we can see that that works. And I've actually got some logic in there as well that when we jump, we actually go through our knees a little bit. So yeah, fun stuff. Again, not fully working yet, but the bases are there. All right. So in this case, we're going to just add that to our linear velocity. Now our velocity is already divided by delta, so we should be getting a velocity in meters per second. And I can put that like that. Okay. Sorry, vector 3. So I'm actually going to test that over here. Yo, Bluggy,
Hello.
you good?
More friends are watching the stream. I'll see if I can get in camera.
Okay, so because we're not actually moving our foot that's on the floor to show that we are doing something, we're only doing half of our animation right now. And we're doing it in the wrong direction. So that needs to be negative. Let's see how that goes. Oh, it's not happy about that at all. Now it's just hopping in place. That's weird. Because that should be calculating it slightly forward. Now, one of the things that could be going on here again, obviously, is this a problem? No, it's not a problem for that. Okay, so. All right, so let's do something to help us a little bit. That's now set to 0. It's about time that we get some 3D labels in here so that we can actually also see it here. Oops, I want my avatar thing. So I didn't have my debug UI, which is the UI that we're seeing in. I'm actually going to get rid of this, I think, because I'm actually not happy about what we're doing here. So I'm going to go and get rid of that, and I'm going to actually clean up the code that belongs to the debug UI. Which means that we're going to get rid of these. It's going to start erroring out on all of those, which is really cool. So yeah, we no longer care about you. Because again, we're going to start doing everything in editor, and then this sort of stuff doesn't really matter. And I'm actually going to go and do that. We might do something with that later. So what we're now going to do instead is we're actually going to add a label 3D. And we're going to call that debug info. Okay. And, oops. What we're going to do here is, again, an var debug label 3D. So again, this is where it becomes important that we type it because it just becomes so much easier. In this case, we're going to do debug label dots visible is debug enabled. There we go. So that's not going to be visible. Oh, there's actually no text in there, so it wouldn't be visible anyway. Oh, and of course, because we I think that's going the wrong way. We'll deal with that in a minute as well. But yeah, that is going to be hidden by default. There, obviously it's going to be like that. Okay. So one of the things that we are going to want to do. Oh, is that a property? It might be a property on this. Flags. Billboard. Yeah. Enabled. All right. So now that is always going to be facing us, so we can actually read it, regardless of which way we're looking at. Billboards are cool. Go away. All right. Where is that actually? Oh yeah, because I'm not doing anything with my angular velocity yet. So keep complaining about that. That's fine. Right. Now the other thing that I'm thinking about is I probably want to visualize the linear velocity as well. Yeah, that would be cool. That would be cool. Because that will also help us a lot. Because with that, we can visualize what we're doing. All right, so I eventually want to add some text to our debug info, but I'm not going to care about that right now. What I am going to care about is to do, actually, I probably want to do a node 3D. Okay, what if I call this debug? And I'm just going to call that info, which means I'm going to do that is now going to be debug/that, because now I'm actually going to go and do this. And I'm just going to go enable that. Now we can make that even better by moving these two in here as well. There we go. Which now means that we no longer need you, and we no longer need you, because everything is within that debug. But these are now going to be wrong. That is not good. That is not good. All right. Let's also move those into ready-ver. So that is going to be on ground debug. What are those? They are messages, but I don't care that they're messages. I just care that those are that. So that is now going to become debug/on ground debug. So this is where actually the autocomplete gets in the way. Sometimes it doesn't want to close. Okay. So with that, I can now do this and this. And I obviously need to do that here as well. Okay. Off ground debug. Just going to be lazy and do it like this. Ah, come on. All right. Cool. Go. So now anything that we put under this debug node will only be visible when we've got our thing enabled, which means that I can make all those, because that's now going to go like that. Just for helper sake, we're going to do it like that. All right, so now we're going to make another little helper scene. Actually delete that. That should still work, I hope. Ooh, what the hell? Global transfer with value of type transform 3D. 238. Why am I getting you? 238. Can't I do it? No, I can't. 238. What did we mess up? On ground. Global transfer is that. Okay. Oh. Yeah, that came from. So this is one of those situations where we change something while the scene is open. Obviously, that means that that never got a value, and therefore it doesn't know what to do with it. So that's fine. Okay, cool. Let's make sure that everything is still working. Everything's still working. Very good. Happy. All right. So now what I want to create is I want to create a helper, which is called axes. We're going to rename that in a minute, but I want that just to be named that for now. We're going to add 2 mesh instances to that. That is going to be stem and mesh instance, and that's going to be called a head. Okay. Right. Let's go and save that as scene in avatar axis. Yep, there we go. Save you as well. So our stem is going to be a cylinder. There we go. And that is going to be nicely little. Much more little than that. Something like this. That'll be good. We want to make that 0.5 meter because we're going to be scaling that. And that also means that actually this is way too much. That needs to be like that. And all right, no. Here we go. Let's go and favorite that and favorite that. For anybody who doesn't know, the favorite option is fairly new. That moves much used things up there. So, and also, I don't know if anybody knows that, you can actually do calculations in these fields. So we've now moved that up by that much, which means that it's over there. Now, I'm not quite sure if I want to actually do that there. I actually think that I'm going to want to do, no, not that one. That one. And that means that I want to do it like that. No, not like that. That makes no sense. So I do want that like this. I got that mixed up. Okay. And I said you need to be 0. There we go. So we're going to put it on that axis. Because in theory, that should mean that if I use look at, it is going to be looking at the right spot. And that's something that we need to test. But for now, we start with that. So that is one thing. Right. And let's give this thing a head. And for that, we're going to use another capsule mesh. No, not a capsule mesh, and another cylinder mesh. But here we're going to make the top 0. The bottom, we're going to do 0.1. And the height is going to be the remaining 0.25. Then we need to do, back up, do the same here, 90. And that means that we're going to go, nope, not that way. Okay, cool. But now minus 25, I think. Yep. And we have a arrowhead. Yay. I think it's actually too big for what I had in mind, or that one's too small. But we can always scale it if we don't want the full length. I think that indeed this one needs to be wider. So let's go for that. Okay. We have an arrow. Yay! All right. Actually, I don't want to call that. I think that's the wrong name for it. File system. We're actually going to call that vector. Rename we go. And that scene is going to be called vector. Boom. Cool. And just vector. All right. So we want that to be somewhere up here. That. There we go. Boom. All right. Cool. Sweet. All right. So where's our onready here? So what I'm just going to do now, we just want to test if this works. So debug / test a vector dot look at vector 3 0 0 0 0 100 minus 100 actually, and leave the rest the same. So is it actually running? Let's do plus 100. Now it's going that way. So it's pointing the wrong side. Haha. Okay, so that means we can just do that. Or actually, no, I'm going to do it like that because I want to use that lookout. And that's going to be minus 19. There we go. I know it's pointing in the opposite direction, but the lookout function by default is pointing in the negative direction, and I'm happy with that. All right, so that would now be minus 100 and pointing in that direction because that's the positive z, that's the negative z. We're pointing negative z. Cool. Sweet. That's exactly what I want. So let's go and rename this guy and say that's going to become the velocity vector. Okay. And we're going to have some fun with that. So velocity vector. So here we can say if debug enabled, we want to go and update that. So now we need to go and calculate what that vector is going to be. So we're going to use linear velocity for that. Now, is lookat in global space or is lookat local? In global space. Okay. So we're going to do a lookat point is linear velocity. And this probably we need to do something like if we have a length, we're doing that. Else, there's no point in showing this. False. And else this is going to be true. Okay. So we're going to go and do that. We're looking in a certain direction. That actually needs to be all the way around. Global transform times linear. Okay, and that's going to be like this. And it actually needs to be minus linear. Okay, cool. So actually, let's see. Make sure that isn't used yet. We're eventually going to scale it by that as well, so that the bigger our velocity is, the bigger our arrow becomes. But for now, I just want to do that just to see if it works. So with that, when we go into, I should have actually already hidden it, but it could be Again, because we haven't done that. Okay, that's because, of course, we only run the logic if we have the debug enabled. So it should be doing something in here. So in here, I wonder why we're only moving left to right. Still, we have it pointing. Okay. But also, why is it... Why does it have a downwards velocity when we're actually not falling? That doesn't make much sense to me. My OBS Studio just said that it lost connection, so I hope I'm still there, guys. There we go. We reconnected successfully. So I hope that didn't cause a dip in the stream. All right. That is still 0 because we're not using that. I think that should be positive then. I think that's what we're doing wrong as far as the... Yeah, so that's going in the right direction now. But why are we going down? Okay, so... Okay, the first thing that I want to do is I do not like that it's so far up. We're actually going to do the velocity out of the middle of our character. Just so that we can see which way it's going. The other thing that I want to do, just for fun, is we're going to go and create a script here. What we're also going to do is we're going to create a material here. And we're going to just create a normal stand-up material. And we're going to copy that material, and we're going to go and put that over here. The reason why I'm doing a copy is because that material is now the same. And actually, what is always nice is to name this one and say this is vector material. Also, what we're going to do is we're going to mark this local to scene. So every time we use the scene, every scene gets its own material. However, that is not right. Maybe because I haven't saved it yet. Okay, so that didn't work the way that it's supposed to, probably because I didn't save first. So let's do that again. Copy. And now paste. Okay, so vector material is that. So both of them have the same material, which means that if I make a change to the material, no, albedo. Where are you? Albedo. If I change the color, both the stem and the head change. What I want. The other thing that I want to do in this is, no, shading. We're going to make it unshaded. Doesn't need to have nice shading. Just becomes a nice white thing. So, so we've done two things here. One is the material is now the same for both. But the other thing is we have made it local to scene, which means that every time we use this vector, everyone gets their own scene. Now, the other thing that we want to do is we want to add an export var here for our color. We're going to default that to color 1, 1, 1, 1. There we go. Perfect. But we're going to do a setter there. Value color is a value, and if is inside tree update color. There we go. That now needs to become a function. So important to know is that properties get set before our scene is completely loaded and instantiated. So if we would directly set our color on our material in this code, we would have the problem that the material actually hasn't been created yet. So we're too early. So that's why we're saying that we're only doing the update color if we are inside tree. That also means that we need to say, once we've entered the tree, we want to do an update color there as well. So at startup, we set the color. And when the color value changes, we set the color. So what are we going to do in the color? We are simply going to get our material. And we're going to get that from dot override material override. So now we've gotten a copy of that material or a reference to material. So that's the material that is used on both of these. And we can now simply say material.albedo color is color. And now for the final bit of magic from that, I am going to reopen this. Final bit of magic, we're going to turn that into a tool script. And that means that if we are over here and we are over here, we're going to make that visible. I can change the color of this to say a nice blue, and it changes right away in my interface. Aha. Even though the color here is still nicely white. And if I would create a second one, let's keep that too, and say that I would rotate that like that, just as an example, I can change that to another color. And there we can see that it actually breaks. So I think that is because I made a duplicate here. Okay, let's go and see if that fixes itself if I reload it, if that's just a problem out there, or if there is a real issue here. Yeah, now it is actually working. So because I duplicated that local to scene thing didn't work. So probably if I would have done it like this. So I would have said, let's do this, vector scene. We can already see that that one is nicely white. So because I duplicated that, there's actually a bug that it doesn't do the local to scene thing. It's a loading function. So this one I should now be able to again change without affecting the other arrow. So there we go. We can find some limitations of these things. All right. So with that, we can now see that that still, for some reason, is pointing downwards. So why is that? Oops, that's not the one that I wanted to do. That one. So let's also... Yeah, exactly. Because I copied and pasted it instead of reinstantiated the scene, it took a little bit too much there, which is, it is what it is. Okay, so let's go and what do I call that? Debug info. Did I not keep that? Debug label. Call that debug info. That makes more sense. Because that is what it is. All right. So debug text is velocity 0.2f. X, Y, Z. There we go. Okay, that's because I renamed you, so you're not suddenly don't exist anymore. Okay, perfect. So yeah. I think I already know why. Because I'm taking the global transform of my character, I'm actually pointing it towards or taking it from there. And then my look at actually goes somewhere over there. And that's why it's, yeah, okay. So we took the wrong global transform. It was not a problem of our velocity. It's a simple problem that I am dumb. Cool. So what we can do here is simply take the global transform of it itself and offset it by that. Okay, let's see if that makes more sense. Well, okay. All right. So that is where, yeah, my own mistake. I'm making this more difficult than it should be. The reason why right now is because I'm taking the global transfer of this while I have just adjusted it to that. So I need to do that based on its original position. All right. So then the start the transform 3D is going to be it's just going to be the end. Start with an empty transform. Then t dot origin is going to be dot position, and t is going to be global transform. Oh, I can just do that like that now. So that now becomes global transform times t times linear. Something like this. It'll probably do it. There we go. Yeah. So now we've got it pointing indeed in the direction that we are moving. And we got it moving in 1 meters per second in that direction. Cool. Okay, that is making perfect sense. Cool, so now we know what it's doing. So now the big question is, why wasn't this working? So it's nicely stepping in place, but it's not. So we're going to 0 to 1. Okay. And forward was indeed -1, backwards is indeed 1. So that is correct. All right. So with that, we know that that little bit is good. Still have that 1 foot being set on the wrong axes, but that's okay. We're going to figure that out in a minute. But now he's balancing on one spot. Okay, that's cool. There we go. All right, so we're starting to get closer and closer. At least we now can see that that bit is, the velocity is correct. It's not doing what it should be doing. And I think one part of that will have to do with us actually standing still. So I think one thing that we're going to be doing right now is with our added velocity, we're going to want to move the foot that is on the ground backwards. All right. Cool. I want you to be disabled again. Okay. So we know that works. We're probably gonna actually, I'm just gonna comment it out for now in case we want to get it back. But I do want to get my velocity vector in there. That's actually kind of handy to debug. And one thing that I really want to do here as well is we want to do this scale. And we're just going to do scale velocity. Actually, that should be scale is vector 3 velocity. Cool. All right, so oops. So now we have that the vector is actually scaling based on the actual velocity that we're walking. Cool. And then if we go in here, we should be able to see the same thing. That the bigger that goes, the bigger our arrow. So we get a nice visualization of how fast we're going. Again, the more information we get for ourselves, the easier your life will be, and the faster we find out where our problems lie. All right, we don't care about that at all. Okay, so we got a linear velocity, that's all good. Right foot, and we get our delta. So let's go and have a look over here. So we cancel out our vertical movement. That's cool. We then do our velocity over here. We do a little bit over here. What I really want to do right now is just say debug info.text is velocity is going to present 0.2f and step time is 2f. Have that too. And let's go and put those two in and see what we get. So velocity and feet step time. There we go. Sweet. All right. So we get our step time, which is a minimum of 0.1, which is cool. And then as we increase that, we see our velocity increasing all the way to 1 and our step time increasing as well. That is exactly what we're expecting here. So that part is also working. Alrighty. Cool. So we're doing that. So we could actually move this down a bit and say we also want to see what our factor is. And that should, yeah, that's going too fast, going from 0 to 1, but that's fine. Eventually we'll want to do a nice scale on the delta, but we'll need to figure that one out. Okay. So that is all looking pretty much what I would like it to look like. So here we're going to make target, offset, linear offset, angular offset. So if we go look at that, time left. Okay, hold on. Let's go back to where we were. So we got our offset there. Cool. Time. It's kind of got to be the same problem, isn't it? This is where we sort of need should graph some stuff as well. But okay, so that part of it looks good. We got our offset here. Time left. Okay. So what we're doing here is we're starting with our offset, and then we're adding that in. And then we're returning our target transform. We also want to do something visible with our collisions here. And I'm wondering if our collisions is working in editor. That's a worry that I have. Okay. So target transform. Off-ground debug global transform is transform. So that one is being positioned where we want, which would suggest that we are not calculating that correctly. Okay. Let's put time in there and see what that does. Hammer velocity. We know what a step time is. Would have been nice if we could graph that one so that we could actually see what's going on, but I would say that that's definitely getting us a calculation. The other one, what is our offset? Okay. Just gonna go and replace that with that, so that's good. So that nicely goes from 25 to minus 25, yet that's not moving. What am I doing wrong here? What are we missing here? All right. Copy this case. Go and do that. Dot origin. Let's see if it makes this into anything remotely sensible. Okay, so that is exactly what, well, on that, I expect that indeed to be minus 25, 25, but I do not get why it's then not actually positioning it there. 0, 0, whoops. But it's definitely not adding our velocity in there. Okay. And I'm guessing that that just means that our time factor is just getting too small. That makes no sense. That makes no sense. What am I missing here? With our velocity, we should be... Oh, because I put my velocity out. So yeah, exactly. So we can see that that keeps moving forward. So why... Oh, with our velocity, we are making that quite small. And that goes back to 25, but it's only doing one leg. It's like it's not updating the other leg. Okay. And then that kind of makes sense because it's definitely something with that first leg. And I think it's a switch around. So that goes to our that. And then we have that, which is also something that I want to do, is and this we're just going to put in there. I don't really want to go and move that away. 0.01 is good enough for me. There we go. And we probably want to do something with the material here. Geometry, material, standard material. There we go. What I want to do here actually is never, so that we always see it. That's way too small. Way too small. 1, 0.1, 0.1. So there we have. Still not doing that test stuff correctly. Alpha. Oh, that's not what I wanted. I want to have no depth test because I want to just always see that. And then we're going to go and give that a bit of a funky color, but we're going to make that transparent. But at least we can see where that is. All right, cool. And we do that for that one too. So we can see where those guys are standing. Okay. Yeah, definitely not making sense. You know, just by the fact that it's like it's only updating 1 foot. Okay. So let's go and hack something in. I'm just going to do this for testing. Okay, so that should keep it on 25 even when we increase it. And still we can see that our feet are moving together. So yeah, we're screwing something up, but I don't know what it is. All right. We'll get there. Sorry, I didn't also want to do a mesh instance temp here as well. But this one, I want to make a little bit more visible. Keep. You know, this is where boxes are really nice. You just put a box somewhere, position it where you want, and all of a sudden we can see what we're doing. So I'm actually happy for that to what? Why am I not seeing? Oh, because haha. There we go. I'm happy for that just to be white, because we're just going to do that temporary anyway. And what I'm going to do here is we're going to start with over here saying debug slash temp slash transform is transform. Okay, boom. I was afraid of that. We need to reopen that again. What? Don't do that. Okay, that makes even less sense. Or does it? No, that does make sense because that is exactly where I expect it to be when we're moving our left foot. And then it goes back to our right foot. Okay, so when I now start moving, we can see that that is exactly where I want it to be. All right. That is exactly what we're expecting it to be. Cool. All right. So we know that's good. Okay. So now it's going to be something's stuck again. My keyboard is being nasty. Something's not working right. Okay, there we go. Come on. So now I'm going to do it here, but now obviously I need to assign the global transform because we've made it global. This should still be working. If this doesn't work, then there's really something weird going on. So we can see that our position is exactly what we want it to be. Cool. Sweet. Visual debugging, guys. That's how it goes. All right, Derp. Thank you for visiting. Good luck with your game. All right, so here we have adjusted that. So let's see if that is something that causes us problems. Let's see if that breaks it. I think it does. I think it is indeed, as I was expecting. Yeah, it is our collision logic. So testing for raycast, we're testing our raycast, blah 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 blah. And that is returning something. So what am I doing here? Do a raycast to see if we move our foot up, down. We can only do this if our parent is a collision object 3D. Yay! Okay, so we check if it's a collision. Cool. Then we get our physics information. We are going to go and do a physics check. All right, if that's not empty, we do that. Oh yeah, that's right, because I'm doing it at the front of the foot and I'm doing it at the back of my foot, and we are getting a return value. And that's to make sure that, you know, we don't clip a foot through the steps. Okay. So that part of this works. So now the question is, what are we doing with this? All right, let's use this again. Okay. All right. So we are getting a collision. But it's not getting something that makes sense here. Let's go move in here. Yep. Let's see what sort of raycards we're doing here. All right. That is doing exactly what I'm expecting what I am expecting it to do. When I do that, again, doing exactly what we would think it is. It's going from nicely high to there. Okay. Interesting. All right, let's go. Move that here. And now I want to do another grouping. I'm going to call that collision. I'm actually going to do here A. Now we need to have X, Y, Z. That's becoming a really big thing. And here we're going to say collision B. All right. So somebody always going to say B. Okay. Well, that's completely correct. It's saying where it is. Our distance is nicely updating as expected. And it's going 0. Okay. So that's all working exactly as I think it should. All right. So we're trying to find the one that is the highest. That makes sense. Oh, but that one is offset, isn't it? Okay, hold on. Bonk, bonk. Let's say var plus vector 3 is that. Pos. And now we just want that to be pos. Okay. So there's a slightly offset position. Oh yeah, because I've still got the query with that. Okay, that makes sense. So the question here is, let's do this slightly differently. Leaving text is nothing. And now for pus in rats, that is now going to be plus is call. Oh, I don't want to call anymore. We're going to do a new line after this. So now we're going to return all results. So perfect. So we're getting only a single result, nicely on the floor, left, right, left, right. And it's working the way that I'm expecting it to work. All right. It's adjusted by global position, which right now doesn't matter because we're at the 0 position. So this is still working exactly the way that I expect it to work. I am getting very confused of this. All right, so I'm going to go and comment that out. So let's go back to here and see what we have over here. Is there anything? Okay. Yeah, idiot. All right, that kind of makes sense. Yep. So the problem here is our default position is getting in the way. Here we go. That only goes wrong if we're exactly at that spot. Oh, that was dumb. All right, well, that was our bug. So that is starting to do something sensible. Not everything yet. That is because right now we are not actually sinking down our knees because we're kind of going to do that eventually. But we do now have that we're removing that and that. So now we need to look at okay, why are we going exactly to 0? Why are we not going? Oh, that is because I'm assuming that the body is moving forward. So that's the thing that we still need to do is pretend that our body is moving forward and thus adjust our existing positions accordingly. Okay. All right. We're getting there. But at least now we've got our stance properly, so that's cool. Man, we're just gonna just get the stream. All that we're gonna get time for this stream is to get the basic logic there. So we can already see that that is now doing something more sensible because we're actually moving. Although again, that is not the right sort of thing. So yeah, we're gonna go back to that. All right, so for our debug velocity, we now need to add logic that makes it pretend that we're moving back. All right. So let's start with this. Okay. So here, what we want to do is on ground transform dot origin is going to be plus is on ground transform dot bases times this times delta. Might be the wrong direction, but we will see. So we're adjusting our on-ground transform and therefore our debug by that. And that also means that we are going to have to let's see. I think we now need to do something like this. And then if left foot, then it's going to be right foot target global transform is on ground transform. Left foot target is that. Okay. Okay, in the wrong direction, but it's doing something. So with that, actually be having that. So, okay, cool. Okay. Getting there. No, that actually makes sense now because it's when we actually put our foot down on the ground and we've moved that far forward, then we have our foot on the ground. Although I'm wondering if that should still be somewhat forward with our foot. Because one of the things that we don't have in this simulation at the moment is that our character should actually be sinking in a little bit, I think. The other thing that I'm wondering about is if our magnets are being repositioned properly. Okay. Now, one thing that we can now also change is where was that test for that? Can we move this? Okay. So this meant now that we get that. So yeah. Tiny baby steps. All right. I still think that our magnet position is probably wrong, and we're not updating our magnet's positions properly. But I'm also thinking that the moment we put our foot on the ground, we are always having our foot underneath our body, and that's wrong. Yeah, that's something, but also the problem that I'm having right now, and again, it's a bit hard to see because we're pretending to move right now. We're not actually moving forward. But the thing is that we're actually putting our foot down in the wrong spot, I think. Because we're always putting our foot down when we're already above that. And we're supposed to, when we walk like this, we're supposed to put our foot down where we are. And again, because we are now simulating it, it's a bit hard to see. But I think that that's a problem of what we're doing here is we're not putting our foot down at the right place. DK, yeah, it is. It is definitely a really bad walk at the moment. But we're getting to somewhere where we want to be. Oh, what the fuck? We're flying! Boink! I'm not quite sure what I did there, but I got launched into the sky. That was hilarious. All right, so here we are seeing that we're putting our step forward. We're seeing where we want to put our foot down. So we're seeing where we're trying to get to. But we're getting there once we're actually above it. And that's I think, wrong. I need to figure out, okay, how can I get to that point? Earlier. I don't know. Yeah, it's definitely true that it might be easier to see what's going on if the ground will be moving as well. Because it's almost like we actually want the target to be at a steady place until we put the foot down, instead of the target moving back to the body. That's, I think, what we might be doing wrong here. So when we are calculating our target, looking at our time left and where I want to get to, and I think that's actually wrong. Stop time. That's our velocity. How fast are we going forward? Okay. What if I do this? Oh. That's not what I had in mind. What does that look like? That actually makes quite a bit more sense. Because we're trying to put our foot there and we're going up there. That makes more sense. Okay. How does that look like if we're running it? Okay, we still have that weird jump. I need to figure out why do we have that weird jump at the start. Full damage. All right. That actually kind of makes sense. I think it actually makes a lot more sense than what we were doing before. I'm not sure if the distance is right. Speed walking. Bing, 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 bing. Bing, bing, bing. But I actually think that that does look way better. Boink, 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 boink. Yeah, that does make a lot more sense. Oh, doesn't allow me to do negative. It should. Should be able to go backwards. I guess I don't. All right. All right. Still a wrong look at how the feet move. But the idea is there. Okay, so. What's next? I'm happy to remove you. I'm happy to remove you. I'll keep that for now because that was kind of handy to see what we're doing there. Although I actually think that that's good now too. So let's go and remove that, but we have to find it. There we go. Boom. Else we get an error. Yeah, that's very likely, Pecker. It's because I never was able to tune the values, and that's the whole reason why I'm doing this. So now we need to start looking at, okay, how are we doing that? Because we're purely basing this right now on where we're placing our feet and adjusting things based on that. So we can see, like, step there, boink, 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 boink. Now we can also see our foot movement properly. Procedural walking in general, but for me, a VR use case, so that if we move around a space, the feet just position themselves in a semi-logical position. So it doesn't have to be perfect, but the walk definitely needs to be better than this. But there's a couple of other things that we can improve. Like, for instance, one of the things that should be happening is that the body should be leaning forward when we're moving like this. And we always want to keep our body above our position. So we want to make sure that our body actually moves a little bit like that. So that's something that I still need to do in here, but I don't think I want to do that first. I'm getting tired. That's the problem. Because one of the things that we can start doing now to create things is, for instance, that's just the speed. That's fine. So we could, for instance, play around with that and see, like, how is that affecting the walk? So this is how high our feet go. So now we can see that the feet hardly go off the ground. We're lifting our feet up a bit more. Makes it hard to see what it actually is doing. Anyway, I'm changing it on the wrong place anyway, because that's actually on the on what we have here. Now, what else did I create? Hold on, there's a step height. Height over step as progression of time. But here I have our maximum foot has, oh yeah, so this is just the faster we go, the higher we actually get. So, we can get the maximum height up and down that way as well. Offset. What is this about? What is that offsetting? Oh, I think that is the how far apart our feet are. So the faster we walk, the closer I want the feet to go onto the middle. So if we could put that a little bit down, where are we with the? Oh, down here. So if we go and put that like this, so you can move that closer and further away. I might actually want that to be more like this. And then we get that, so cool. And again, I'm updating this in the wrong place now, but Now that's just purely feet rotation, so that doesn't do a whole lot. Okay, so the other one that I wanted to do before we call it quits is I actually want to go and visualize our magnets. Oops. Box 0.1, 0.1, 0.1. Right. So we can see where those are. And now when we start working, see that those are adjusting as well. And I think they're completely in the wrong place. But one of the other things that I wonder about, so yeah, these need to actually move along as well. Let's go and take care of that. Debug velocity that. So doing all our on ground transforms here. Okay, so I'm almost thinking that I'm going to do this. I'm going to do that with the remote transform. I'm going to go and take that out. And here, right foot magnets. Left foot magnets is only one time here, so we no longer need you. Right foot magnet, we no longer need you. But instead, what we're going to do is, why is this so screwed up? Is that because it's, I think this is because we don't have any, we're not colliding, so it doesn't know what to do with it. I'm not going to worry about that bit right now. There should be a way to figure out whether we're actually placing this in the correct position. I think I need to do something that if none of the feet are in the touching the ground and we don't have any velocity, we move the feet back to their default position. But I'm not going to worry about that right now. So what was I doing? Oh yeah, I wanted to make sure that our things are actually in the right spot for this. So what we're going to be doing here is, oh, not there. We're going to do that. We're going to say remote transform. This is going to be called magnets pulse. That like that. We're going to move that like that. And now we're going to go and say, this is the left foot, I think. So that's positioning that guy. There we go. Perfect. And now we do the same for the right foot. Why is it actually going like that? Because we really need to make sure that if we're actually not Oh, that one is indeed all the way rotated. Weird. Okay, so I need to figure out a nice way to actually completely disable this. Okay. We'll deal with that another time. Okay, so the same thing here. Transform. That's close. Let's make it something nicer. 0.5. 3. Really? Oh yeah, because we're moving that so much forward to that. Okay, that's fine. So 0.5, 0.3. I probably can duplicate that here as well. 3, boom. That is now our right foot magnets. Okay, boom. All right. So I think I'm going to add an enable general thing here because okay. So we're going to go and say over here, export var enables false, enable positioning logic. And what we're actually going to do with that is dig. There we go. And here we're going to say, if not enabled, we're just going to return our rets. There we go. And what are we doing right now? If we're not colliding, I'm actually thinking that if we're not enabled, we are simply going to why are we doing it like that? Oh, because we want to do that. Okay. Maybe a little bit overdone then. Transform. Okay, what if I go and move that over here? That's. And that means that these are all going to be. No, it doesn't matter, actually. I'm going to have to do it like this because this is all done in global space. So I'm always going to have to do that. There's no point in optimizing for that. But in this case, we just want to have our, sorry. Okay. Oh, my eyes are stinging for some reason. I wonder if they're back burning somewhere. Okay. So, and I think with that, we're pretending that we are doing that. So now it's indeed Well, that's in the wrong spot, but that was kind of logical because our target was the wrong way around. Let's see, that one is minus. That also needs to be minus. There we go. Cool. All right. So now with this disabled, okay, we can see that basically the animation is still working. We're just not doing anything with it. And even if we do, oh, that's because we still have we're moving forward. So it just disables the physics part of it. Actually, you know what? Feet. We're gonna rename that to feet physics enabled. Enables our feet. Enables physics. Our feet positioning logic. Okay. So. All right. There we go. Perfect. Happy, happy. Means that if we do that, we are still doing stuff. He's walking. He's walking. Very good. I don't know why the negative doesn't work. I need to look at that too. So now with the physics disabled by default, because that will be not enabled, let's go and reopen that, or that will probably fail as well. All right. So now when we... stupid bug. Okay. So now we can see that it still tries to do that. Now, again, in editor, it doesn't like that, but because our physics is disabled, it's not going to go and do that. All right. But if we do enable our physics, and of course that immediately goes bad again, and we can see that now it actually goes up there. Now, in this case, we don't have that logic in there because our body physics aren't enabled, but we do have that our feet are being positioned the way that we expect them to. Now, in this case, we go wrong because I'm keeping that foot on the ground. I'm not doing that. I still need to make some logic that depending on how far forward we are, we actually start falling down. But that's for later. So go back to 0, go back to 0, boom. Cool. All right, obviously we want to have the physics enabled on our main one. We only want it disabled in our avatar thing. That's fine. All right, so. And again, we are still flying off for some reason that I do not understand. Yeah, we can rotate while we're in the air. That's interesting. All right, we're falling. Whee! Oh, we're falling faster and faster and faster. When are we hitting the ground? And we hit the ground. Okay, I really need to figure out why I'm flying off in that first frame. Yeah, we got that. Walking. But the thing is, we can see that is definitely very wrong because of the way that our magnets work. So let's figure that one out. But why is that first step so wrong? I think it's because we're basically halfway there. So if we go from standstill, we should be taking a half step. So we need to do something there that we detect what was our last step timing. If we go from standstill, we should have our first step be half. Yeah. Yeah, so we still don't have the, we're not going backwards properly. So I need to figure out about that. Oh, I think that's possibly the reason why. Yeah, I definitely think that the way that we are doing our magnet calculation is wrong, but because we're doing it based on our target and not where our foot actually is. So yeah, not quite sure about that one. Yeah, the region thing is pretty cool. That's a fairly new feature where, because now you can just go and do this and sort of clean up your code a bit, make it a bit more readable. Makes it handy. Oh my, I think someone's back burning. My eyes are stinging for some reason. Long live living in Australia. Well, it's better than bushfires, I guess. So yeah. Yeah, I'm gonna need to find a better way to do those knee magnets because that's definitely not the right logic. Okay, so our first step is wrong, which makes sense because we're going from standstill. Well, normally you do a full step, so your back leg is actually already halfway where it should be. So yeah, when I calculate that, I need to okay, so how are we doing that? Yeah, it must be dry air then. Because I'm not smelling the back burning. Normally you smell it. So it's gliding and time is that. Is on the floor, is gliding. So this is definitely where we need more logic for when we can start falling down. All right, so the thing is here, we are calculating our step time based on our velocity. Okay, let me think. Hmm. I think what we're going to do here, variables, step, okay. So here we're going to say, when our animation is finished, where is it? It's here, no? Why can't I see it now? Let me go. Here, so when they're finished, this is definitely wrong, but we need to, so to do fix is gliding No, the joints don't have limits, Stasis. The IK logic here is incredibly simplistic. So maybe one of the things that I need to start looking into is better IK logic that does have joint limits instead of using the built-in logic. Okay, so here we're gonna say is velocity. No, velocity will always be velocity smaller than. I'm just gonna say 0.1 for now. So if when our foot comes down, our velocity is near 0, then we're gonna assume that when we've taken a step again, I'm actually gonna make a. I'm gonna put that here. If our velocity near standstill, the next step we take root assume to be a first step in a walk cycle. And what we're going to do now is step time. Here we're going to say if first step, then step time is half. Okay, I need to find out why is it suddenly flying up? Where is that coming from? Right, it has to be something like this. On ground origin. Yeah, so that's where we're going wrong. Nope, that's not where we're going wrong. So where's that initial velocity coming from? Okay. So this is the only place where we are adjusting the velocity of a character body. That's just applying gravity. It's localizing it. We got that one. We got that one. X, Y, that's fine. And then that makes it. Oh, yeah, that's right. That's how I get that on the Y. Okay, plus. Y damp is 10. Delta is a little. Okay, where are we? Oh, that's already really big. Okay, stop. All right, let's just see. Very first frame. Velocity is 0. Okay. 10. Okay. So velocity is 0. Velocity becomes big. Why? What the heck? This global base is not set on the very first frame. That makes no sense. Got a rotation, that's fine. But, we're doing over normalized. inverse. Okay. Okay. Still, what? My velocity is 0. My basis is a normal basis. And that becomes something really, really weird. Okay. So it's not this. It's something with the velocity. Okay. Okay, how do we get a crazy velocity at the start of on our first frame? That makes no sense. Where is that coming from? This process. I'm pretty sure that that runs before this. Yep, that runs before that. We actually even never get there for some reason. That makes no sense. Oh, I probably just put that in the wrong place. Okay. Yeah, still same thing. Continue. Let me hit that one. Continue. Okay. Don't put a breakpoint in a comment. Doesn't work. Okay, so for some reason, our velocity. All right. So what if we do clunk? Ready? Let's see. Reset our velocity. Is there something weird here? Where are you? Okay, I guess velocity is not exposed here, so let's see what that does. All right. Well, that solved the problem. So our velocity is not initialized at startup. I've never seen that go wrong before, and seeing that I'm on a 4.5 dev build, I'm guessing that's a new problem. Okay, so now we get the first step is actually half. But why is it sliding the first one? So okay, that's also interesting. Oh yeah, because that starts at 0. Oh, because also first step, I'm no, that's okay. But I'm doing this at the beginning, which means that when I start my step, Um, because I did that so that I'm not going to do that, you know, up, up, up when I'm standing still. But it means that the very first time I'm not calculating this properly. So really when I start moving, I need to think that through, but it's getting late. It's 11 for me, so I am going to call it here. But yeah, I'm going to make some more notes here. So I'm kind of happy with that. For the first step, we're going to do that. And I'm also going to do that here. If we start step, we should update this, not at the end. Okay. And I think we need to do something more about the distance that we are traveling. Yeah, I'm probably going to do something different than doing it with time. I need to think about that some more. Because I think it might be a nicer idea to say, where is my foot currently? Or I should really say, where is my on ground foot in relationship to the current body? And my other foot always be opposite of that. And that distance, that is going to determine how far in my step I am. Especially because I've got that target right now as a fixed one. Yeah, I'm gonna make a remark about that in here. Let's see, more foots. Okay. Note for next stream. Consider all right, so I'm gonna figure that out. I'm gonna get some thought about that because basically, let's see, where is my because yeah, I am putting that there. I'm kind of, there's really a point where when the back foot goes back far enough, that's really where I need to decide that I want to go to the front and that I want to swap legs. So instead of swapping the legs based on where the in-air foot is, we're going to swap legs based on where our foot on ground is compared to how far we want to move. So depending on our velocity, we want a certain distance. The faster that we go, the further the foot should be before we move it forward. And then when we move it forward, we calculate where we want the foot to go. And we just move it there as the other foot moves back again. So it's really going to become, that's actually a really good one. If based on the velocity, we determine when we want to lift our foot off the ground, and then we calculate from that position back to where our foot is. You know, when a foot is halfway there already and only needs to do that bit, that means that that's how much forward our right foot needs to go. So our left foot is, or our on-ground foot is always as far backwards as how much forward the other foot needs to be. So we can make the time interval on that. Yeah, I got to give that some thought. I think there are some improvements to make there on how the walk animation works. Yeah, let me give that some more thought, and that is then a good thing for our next stream. So thank you everybody for staying with me for the whole night. I hope it was interesting. I hope we learned a few things. I am going to place this in a repository for anybody to play with, but it's probably going to change quite a lot as we move from logic based on time to logic based on where our leg on the floor is. Yeah, I think that is a really good way to look at it. Cool. Yeah, I think that is good. All right, everybody. Thanks again for watching. I'm going to leave it there. I've got a little funny thing at the end. My good friend Virtual Rook, check out his YouTube channel. He made a little animation for me for at the end of the stream. Makes it a little bit easier for me to end it. So yeah, enjoy a few seconds of the end screen, and after that, we say good night. So thank you, everybody, and until next time.